Good afternoon, good evening, guys. You know, I know you all have been joining us from different locations on this planet. Welcome to another webinar from Network Intelligence. I'm Amit Dhawan. I am the CEO for India and APAC, and I have with me Venkat, our global CTO, and he's been developing tons of things, and we both will try to, show you what all we've been doing. Okay. So guys, this is something interesting that we are starting this time around. We've created a series called Hack or Not, Decoding Cloud Alerts with AI. The people who have joined are mostly from the fraternity of cybersecurity, and all of us, I'm very sure, are struggling with all these points that we talk about. So, we decided that let us take you through, what all we've been doing as a work, what all technical developments we've been creating here, what all fantastic work that Venkat is doing on AI to bring, the technology to help us solve our problems better. So what we will do is, I think we are here for an hour. What we will do is I'll just quickly update all of you on, or rather, not update. I would rather, just run through the developments that the world is seeing in cloud, in AI, the cyber threats, and I've had my share. I've been a CISO for about 8 years before coming into this role. So, what all threats people see as a CISO, and how do we leverage AI and the technology that we have to reduce those risks, to mitigate those risks, and ensure that our businesses run perfectly well. Okay, so let me quickly share my screen and take you guys through what we have for you in store today. All right. So decoding cloud alerts with AI, and in the future, Hack or Not session. We hope it is worth your while, and we will be bringing more and more features as we move along. But let's come back. What is cloud all about? So cloud came into being many years back, but the cloud is here to stay. We had people were very apprehensive about what cloud is, but cloud is here to stay. If you look at the screen, the cloud spend will surpass $1 trillion USD by 2028. It is roughly around 745, 750 billion US dollars in 2025. And if you look at the increase in the last 5 years, it is almost a 500% increase, a 5 times increase from roughly 156 billion USD in 2020. So cloud is here to stay. It is not going anywhere. And 45% of the organizations now use cloud services. Now, this 45% of the organizations is a conservative number, because a lot of organizations are using SaaS-based applications which are anyway hosted on cloud. They are using tons of things. Your Azure AD is there on the cloud, and people have started using cloud native activities as well on cloud to ease their workloads or to learn or to migrate. But 45% of the organizations are there on cloud. 60% of organizations run over half of their workloads on the cloud. So it is, I've been talking to a lot of CISOs, I've been talking to a lot of CTOs, CIOs, and even practice leads in service companies. All of them are creating their services on cloud. So there is nobody who's anymore creating their services on the data centers. And cloud computing market is just will go through the roof very soon. But cloud is a little different animal. if you mistake the on-premise infrastructure to the cloud infrastructure, you'll be mistaken. The cloud infrastructure is completely different. Yes, a server is a server, a switch is a switch, a router is a router. But the way the things are structured in cloud is completely different from what the way it is structured in a normal traditional data center. And because of this, the understanding of the technology, the understanding of the security controls is still evolving, as we see. And this is resulting in more and more alerts coming in, and more uh, you know non-availability of a skill, if I dare say so, uh, of ensuring that the alerts are well mitigated on cloud. So this threat is big, and traditionally, if you look at the security markets or security trends, the technology comes first and security comes tagging along later. Now, this is the first time when we have the capability to manage the alerts. It's only a different type of alert, but the volume is high, uh, and people are finding it difficult. That's why a lot of teams are facing that alert fatigue. Uh, Cloud environments are very dynamic, and therefore, the with auto scaling, with serverless architecture functions running, by the time the alert comes in and the team start to react, the server probably has shut down, the machine has probably shut down, the snapshot has evolved into another one, the containers are no longer there, and it's a very quick creation and deletion of the infrastructure on cloud, and it has a very dynamic nature, and therefore the management of alerts, the reaction time, it is all very complex. And therefore the challenge comes in is how do you separate uh, the signal from the noise, or right, or identify what you need to solve from all the high volume of alerts that you're generating from cloud. So technically, if you see from first principles, a server, network, but when you look at how they are configured on cloud, it's absolutely different. Cloud trends, I just briefly mentioned as to what is happening on cloud. 70% of the components on cloud are cloud native architectures. What we talk about serverless architecture. Now, we can say it's a serverless architecture, but it is nothing but actually a server or a container which sits behind. And the people who control this are the Kubernetes and the stuff like this. So, Cloud SQL servers, you don't have to uh, install the complete Oracle or MySQL or something. You just rent an instance for some time. The NoSQL databases, traditionally we used to be bothered about the cost of storage, which is no longer a constraint on cloud. So you take the whole bulk of your data, run some queries, and put that data somewhere to pick it up later. So a lot of components are cloud native architectures. The traditional applications, whatever we have, are turning out to be a failure. People go to cloud and they come back. So you have to migrate into a cloud native architecture and run your workloads in that fashion. The other thing is, with the availability of this storage and the availability of this compute that we see now, uh, which has exponentially increased, is also making AI more accessible and user aware, available to the users, from the chat GPTs to anything that we have from WhatsApp having a AI. But large organizations are pushing in a ton of data into cloud for automation, analytics, enhanced decision making, segregation, classification, even predicting things. Uh, Multi and hybrid cloud, and this is just evolving. So we were talking to somebody today, Venkat and I, and we were discussing, how do you plan or make a solution for customers which are on multi-cloud, which are on hybrid cloud. So the traditional solution architecture is also becoming an issue these days. Clouds appears to be cheaper when you start, but if you do not have your cost control in place, it becomes a massive issue for you. So there are a lot of people, almost 78% of cloud users, some of our customers as well, and we are running queries for them to do the cost optimization. 70% of them want to reduce the cloud cost. Earlier days, the server was running and you have no choice but to let it run. But now you can write a script, shut down the server in the night, or have auto scaling that, beyond a CPU percentage, you do this. Less than that, you shut down few instances, and reduce your cloud cost. ESG, or environmental, social governance, is also slowly having its footprint in cybersecurity and IT. And few mandates coming in for green environment. So 22% of people want sustainability and green footprint available. The other element of ESG becomes your privacy, the social part of it. Your data is there, and data protection becomes an important part. And that also needs to coincide at some place, privacy being a governance thing. But technically, when it is implemented, it is about data, where it is stored, how it is accessed, who has access, where is the data flowing. It all becomes very technical, and all those technical things create logs. And this is where the cloud alerts come in. So, ESG, despite being a non-technical stuff, has a lot of value when you dig a little deeper to understand how it works. Hybrid workforce is increasing. We were consulting for an organization very recently, and we realized that people who are working from home are their performance itself of those laptops is reducing, so they need to work from outside. But when they're working outside, their performance is degrading because the network traffic is coming into the firewall, into the IPS, into all that stuff, gateway proxy, ESG, everything sitting inside the network, and creating tons of latency. So people are working outside, but it increases the risk. How do you mitigate this risk? Take everything to the cloud. Okay, take your tools to the cloud. uh, have people become, to make people more productive and a happy workforce with the Gen Zs around us. You have to go to the cloud. You have no choice. But moment you go to the cloud, you invite the other trouble of not being able to manage their logs. So, almost a 250% increase in cyber attacks targeting the remote workers since the pandemic. And a lot of businesses feel that if you have it in a closed environment, you feel that you are protected. Moment people start working from outside, people have that fear that they're not protected. But cloud is, whatever I can say, but cloud is here to stay. But you can manage a lot of alerts on this cloud, and you can resolve a lot of things. And this is actually why we are here. And when you look at it, AI comes to the rescue. The large machines of AI, we can decode those threats with intelligence. We had one case where almost about 3 million alerts came in, and it became a big issue that we had to tell the customers to bring down their network. But when we dumped that whole piece into AI, we realized it was one of the breach attack simulator which was creating those alerts. So separating signal from the noise, it identifies false positives very, very quickly, and it prioritizes the real threats. And this is what Venkat is going to show you in some time. The metrics by which we monitor how our SOCs operate, the MTTT and the MTTR, again gets very optimized and reduces a lot. Moment you start using, you leverage technology and you use AI to connect the dots. I mentioned AI is used for classification, segregation. It is for prediction, and this is where the neural networks, where the storage happens, where the understanding of the stuff happens. You do a contextual analysis and you connect the alerts related to the cloud environments, and you reduce, how your L1s and L2s and L3s react. So it reduces the alert fatigue. You use technology to understand technology and to counter the alert fatigue that you have, again using the technology. So very interesting space that we find ourselves in. And okay, I think my time is running out. I'll take a break now. Venkat, to you to take our guys through the technical work and maybe some more, the knowledge which people can have on how to manage their alerts in this environment.
Thanks, Amit. Hey all, good afternoon, good morning, wherever you are. Let me share my screen. It's probably easier for me to share the entire screen here. Before I show you the screen and alerts, I want to set a bit of context around how we are approaching things. If you look at cloud, the origination point of the alert can be any service in the cloud, including the log stores in the cloud. For example, the origination of the alert could be GuardDuty or Defender, who are aggregating the raw alerts, either from CloudTrail, either from EDR machines, and passing them on or storing them on, storing the raw alerts and so forth, or aggregating them and passing the offenses alerts back. The system that we are talking about is the transilience circle here, where we are getting the offenses from our alerts from GuardDuty, the aggregators, so to speak, and also we are getting raw events as well. And if we don't get the alerts, we'll go back. We have the ability to go back and look at multiple log stores and get the corresponding raw events. So for example, let's say somebody instantiated an EC2 instance in a wrong VPC, or the default VPC, for example, which is a wrong thing to do. It might be a misconfiguration, or it could be a malicious attack. Now, for us to determine that, let's say GuardDuty has detected that and sent the alert, or some CSPM tool. Now, for us to determine whether it's a right thing or a wrong thing, meaning whether it's a misconfiguration or an accidental thing or insider attack or external lateral movement, we need to go and look at multiple things, such as who did that? What did that user do before? From which IP did that user access? What else did that IP do? What else happened after that? For us to do that, we need to go back into the log stores and get the alerts. And the use of AI is in the circle where AI determines, based on the alert, what should I do? What should I check next? And after all the analysis, it also gives a judgment call with regards to what could have happened. A lot of times, even when a human is involved, security is a matter of probabilities. Sometimes you exactly know what happened and it's a close to 100% probability, and sometimes you don't know what happened based on the data, and you don't have time to determine what could have happened, and therefore it's a matter of probabilities. And you would say there is 70% probability that this has happened, and 20% that could have happened. That determination of the judgment is also taken by the LLM here. And when it takes that, it also takes into account what has happened historically with that context, meaning with that account, with that customer, with that environment. If previous alerts have happened, if previous judgment calls have been done by humans, then we would take that into account as well before doing the judgment analysis. After looking at what the AI has produced, the human in the loop will make a final determination and do the corresponding remediation. We're not there yet with respect to AI doing the remediation yet. We think it is close, but not there yet, and therefore a human is always involved in looking at what the AI has produced and making a final remediation call. What I'm going to show you today is a dashboard that AI has generated as well. If you look at the type of alerts that cloud has and the end goal for the user to do, which is you sent me a package, meaning AI sent me a package, and as a human, I need to determine what the remedial actions are. Better the package is designed in such a way that I can quickly determine what I need to do. If it's a set of charts, for example, I need to click through, or if it's a search box, I need to write a rule, then it will take me more time to understand, to learn what the rules are that I need to write, to understand what I need to type in the search box, to understand a pie chart or a graph chart or a stacked pie chart or a spider chart. It will take some time for me to dig in through all that. So because AI not only can is good enough to make the calls, to make the API calls and determine what could have happened, it also is good at representing data. And if you can make the AI represent the data in such a way that the human can act on the remediation calls quickly, then there is more probability that the human can act on the alert, right alert quickly. So I'm going to show you this analysis dashboard. It's not, and again, it's not a set in stone dashboard, one dashboard. This will change depending on what the AI thinks need to be represented. So I'll take you through a few examples. And like Amit said, even there are 3 million, 4 million raw events, so to speak, you should be able to make quick determination with what the AI is saying on what to do if you know a few heuristic rules. So I'll also give a few takeaways that you can take to your SOC work throughout the day to reduce there is no need for you to look at each and every alert, each and every event, if you can develop these heuristic rules of what has happened. So this is the kind of the dashboard, and if you can see, this is what generated by AI after it looked at the alert. The alert is about somebody made some policy changes that are not authorized, and bucket changes. If you look at the risk of it, it could be a data leak where the bucket policy might be no public access, or it might be to just some specific roles, but a policy update could have opened it to multiple locations and multiple roles. That's the alert, and therefore, somebody needs to go take a look and understand it, and this could have happened once or 5 million times. If you look at quickly that alert, I need to know a little bit more with respect to knowing what is the probability that it's an insider attack versus something misconfiguration of a CI/CD pipeline and so forth. Here is the raw alert, and it takes a long time to read through this alert. There is important information, right? So we know that this is a quit bucket policy, which means that it is a policy change, and it is this user. And what we did is we sent this raw alert to the LLM and said, "Go figure it out." So it immediately said, an external IP address, right? So that means this IP address is external, which is easy to do. And then it said the policy got made by a service account. That's interesting because I didn't say anything about service or user. I just said, this is my event, and the name of the user that AI saw is svc-iam-role-app.access. And it thought that because of whatever reason, I'm assuming that it saw the name SVC here, it's a service account. And for a human to do that, it will take 10 minutes, 10 seconds, but it's a lot of cognitive overload where the AI itself has said, hey, a service account host did that. It could be a case that this is a user, but it's less likely that it is a user. It's more likely that it's a service account. Now I am more aware of what happened. It's not a user. So it's a service account. That means that somebody should have access to that service account to be able to do this. And therefore, there is one more layer of access that is needed for this attack to happen. Now I'm a bit relieved from a SOC analyst perspective. I don't need to wake up somebody in the middle of the night because it's a service account. But it's an external IP. And therefore, I'm like, okay, why is if the AI will say, why is a service account talking about coming from external IP? Giving that aside, this activity includes course modification. So for a human to look at the raw event and understand the policy that got attached, that will take, again, a few minutes, depending on how familiar you are with the cloud. But the AI is saying, hey, these are the updates in plain English. Now I know what the policy update is. They're not changing the rules, etc., but they're changing the course policy that dictates which IP can access the bucket and so on and so forth. Now I know kind of what happened. So it's a ISB sourced external IP. That means that it's not, it did some tooling in the backend, call some tools in the backend, and they determined that it's not, the IP doesn't belong to the cloud. The IP belongs to an ISP that's probably not from the cloud. So just from giving the event to AI, it was able to quickly understand the big event. And in 4 lines, it was able to tell a non-cloud engineer, a SOC analyst who is working on multiple alerts in plain English in 4 lines. It said, here's what happened. I can understand this much better than I can understand this from a SOC analyst who is looking at multiple alerts perspective. So right off the bat, AI added value in terms of explaining what has happened in pure English, that a service account has accessed and changed a course policy from an ISP sourced IP address. If you look at the event itself, there's a resource involved somewhere here. What is the resource that got accessed? And it pulled off the involved entities field, and these are the buckets that got changed. So it also looked at, it made a few calls and said, what else did that IP do or service account do? And there are a few buckets it changed. If I look at the buckets, right, now I look at this and I'm like, yeah, looks like that's important. And now when I look at these 3 stages, it started from bucket policy changes. Oh, a service account, so that's okay. But it's an IP from an ISP. That's not okay. And now I see financial data prod. That's important bucket, and therefore I need to take a look at it more. So the cycles that I went through are, as I peel through the onion, whether it's a hack or not, changed 3 or 4 times. And now I'm a human doing the analysis, but imagine an AI doing the analysis. So it got the initial alert. It thought, hey, it's okay. It made a few calls. It said it's not okay. Let me make a few more calls depending on what happened. Now it's not okay. So it's going through this analysis of what else do I need to do to be able to say it's a hack or not? What's towards the end recommendation? It went through the now I need to know what's up with that IP. Is that a regular residential IP? Is that is there an IP that the company resides in? Is that an IP that is coming from a mobile IP or a region that the company does not operate in? What does the threat intel say about that? And even then, the threat intel IP are confidence based, right? Because the IPs get rotated all the time. And now the AI thinks that it's the likelihood is high because that it's a hack because of the analysis it did on IP and the service account it got figured out. Since it's an IP that is not from the geographic location that the company operates in, and it's a service account that got used from that IP, AI thinks that the likelihood is very high that the service account got compromised. And again, there could be a probability that a DevOps person is not using IAM roles for this, and they're logging in as a user using that service account, and he has the DevOps person has traveled on a vacation to a location that the company does not operate in, and there was some bad thing that is going on in the account and in the product account, and he's trying to debug, and he's trying to access the financial data. It could all be true. It could all be an insider doing the right things but in the wrong way. But the probability is high, that is the AI thinks, because of the reasons that it's clearly telling us that it is a insider attack. It also has looked at other activity that has happened from that same IP, that it has not only just did put bucket ACL, which is the policy, and list buckets, but it also did other activity from decryption attempt and cloud distribution and so forth. In the end, the root cause analysis with respect to what could have happened is, this is 8 out of 10. There is something that you need to do, whether it's a real attack, whether it's a go and talk to a person about what happened. There is an activity that you need to do right away before you dismiss the alert, is what it's saying. And the reasons are, all these reasons of why. And the next steps with respect to what should be done is also very important. So for example, if you're using a service account, usually service accounts do a lot of, they are there for a reason, which is you want to operate the environment using accounts that have specific permissions. And if users are using their service accounts, that's bad. And for you to lock those service accounts down, you need specific IPs, and the recommendation is, at least if not don't use service accounts for users, put IP restrictions, put list privileges and service accounts. These things that the AI is recommending right away is, in my opinion, are pretty good with respect to the long-term recommendations. And of course, if you determine that it's a event that is bad, and of course there are immediate actions that is required, which is block that IP address, remove that policy, audit all the rest of the buckets, check for all the persistence that the hack could have left out, such as new IAM users, new ports, new access keys that might have left out. So this again is all analysis of AI doing all this, and once the end user getting this, it is quite easy for the end user to determine, depending on what it is saying and why, and go through and follow these actions. And I'm not looking at these raw alerts and trying to determine what happened and so forth. So my role from a security engineer perspective is looking at security versus looking at JSON and understanding tied to JSON. So my job is also more enjoyable now because I'm looking at security aspect of things than me being looking at a dashboard with lots of JSON and spreadsheets and CSVs and so forth. I'll go through a couple more for you to look at. This is a WAF detection, WAF that got fired an alert saying they got a log4j attempt. And again, the same kind of analysis where I got an alert from WAF saying there's a log4j attack. Now I need to go and into each of the other log stores and IPs and so forth to understand what happened in this case. It made a call to Zscaler. It made a call to EDR. The usual calls to AbuseDB, VirusTotal, etc., to get the IPs, and go through the same kind of analysis to figure out what has happened. So there are multiple security alerts detected. 2 instances have been blocked of outbound traffic has been blocked, and therefore there is firewall activity and there is WAF activity. So just those of multiple CNC with two places, that's bad. These are internal IPs, two internal IPs that are communicating externally, and also there is external IPs involved. So this one-liner, I find it very, very, very useful for doing the analysis, as opposed to looking at multiple places and so forth. So I'm just quickly going through each for time reasons, but you can get the sense of how the alerts are organized in a sequential way. And I changed this a little bit for the next step kind of a thing, and the dashboards that we use are much more. Here is the recommendation first. Here is why I think that, and then go backwards to see, do you want to see information of why I think this, as opposed to the way that I'm doing things with this click next year. So same thing, isolate the instances, patch log4j. There's full malware scans that you need to do, reset passwords of these two users, block the IP, right? So clear recommendations for the user to do, and they ask why, then here's I think it's the likelihood that it's a hack is very high. Why? And then you can go back and say the reason is that it's one IP, two instances of sources, Zscaler WAF, it's saying that, and command and control and so on and so forth. You can quickly trace back the why with respect to what the recommendations are. I'll do a quick thing around a not hack, so to speak. Here is a non-standard an instance created in the non-standard VPC. It's detected as potentially suspicious because that nobody uses that VPC, or this is the first time I saw the VPC getting used. Now, if I see the event, it's again a big raw event that happened, and I can try to understand it if I'm a cloud expert, or try to read some books and so forth on what this means. Or the AI, without because of its pre-training, etc. The role, the analytics, whatever the role is here, the AI is saying that it's from it's a service role that Elastic NavReduce, Amazon Elastic NavReduce uses. And I can do more research on why Amazon uses this role and it is true or not. But from an AI perspective, I think that it is a service account that is being used by AWS. If I click a couple of things involved, the IP address is 0.0.0.0, and that is, I think it says it's somewhere. Okay, here. The IP is a internal service identifier. The 0.0.0.0 is a internal service identifier by AWS. It's not a public IP or a private IP, and therefore, whoever is the compute job that is doing that activity is an internal service activity. It could be that Amazon is upgrading your EMR and therefore it's doing it, or it is backing up into any VPC that doesn't exist yet. So you go on, and it says it's not a hack because it's a legitimate service activity by EMR specific context, and the confidence is 9. And again, the recommendations are to do this from a long-term perspective of taking this alert and so forth. I have a few more alerts, but for the sake of time, I think you get a sense here. I'll leave you with a couple of takeaways. The who, the what, the how, going back to the first principles that Amit is talking about, are still relevant here. But if you remember a few heuristic rules, I think you can quickly determine whether something is a hack or not in cloud. And depending on how you operate, whether you operate your environment with CI/CD pipelines or your DevOps people will go log in from the user accounts. That will make things complicated as well. So is it a user or is it a service role is very important. That's because if you have service roles, if you don't have service roles, use service roles. If you have service roles, then make those service roles very tightly defined with respect to which compute jobs can access them. No user can access them, and therefore you can quickly determine, even if that service role is acting from a non-IP addresses, you can see what has happened and quickly determine whether that service role, whatever that service role is doing, is good or bad. For example, if the service role is did a non-standard activity which looked bad, but it's from a AWS IP address and it's a compute job that is running in AWS, then you can there's no need to panic, so to speak, yet. You can investigate that what happened. But if a service role is accessing something, a resource that should not access from a non-AWS IP address that we saw before, from a home IP address or geography that the company does not operate in, it becomes a red flag quickly. So knowing your service roles, how they are built, what they can access, what they usually do, what IP address they can access from, tightening that would eliminate you panicking about the events that you should not. The resource that's being accessed, we saw that the financial data buckets are being accessed. That if you can limit the applications and roles that are accessing your most important resources, then you can quickly control whether you determine something is a hack or not. Usually, if you use this, for example, an extreme example, but if you use a DevOps bucket with your prod bucket, if you use the same bucket, then of course, whenever a DevOps job runs, it puts all the artifacts in the same bucket as the prod bucket. And therefore, whenever there is a put activity in that bucket, you cannot determine what is noise, what is signal. So controlling your service roles, controlling your resources will make your life easy. And then what IPs? And as we saw, the IPs such as 0.0 are used by AWS IPs. And combine that with the service names that the AWS folks use, it will quickly help you to determine whether it's a hack or not. If you use CI/CD pipelines, that will make your life even easy. You can quickly determine the source of who is doing it using code. So if a user is doing some action, it's in their whatever they're doing. But if a pipeline is doing that activity, then you can assume that there is a source code that is doing the activity, and that source code got reviewed, the Terraform file got reviewed, and therefore you can quickly go to the source and find what changed in that source, who made that change, why did that change got happen, because there is usually a ticket that happened. So if CI/CD pipeline is doing the activity, it's even though it's non-standard, there is no need to panic, because if you have change management practices, then that change probably has happened through normal change management activity and so forth. If it's a type of activity, if it's the right activity, it's more important. But if a user is logging in and they're changing configurations, if you see things like that, that's a red flag. If you see multiple of your sources point into the same activity, such as I saw, guard duty saying you got command and control activity outbound, and WAF is saying I blocked command and control activity, or some log4j, some SQL injection attacks, and also your EDR and VPNs like Zscaler saying the same thing. So having a infrastructure and intelligence where you are dynamically making calls and getting the corresponding events is more important. So you cannot ever write a playbook with regular SOAR to say, if this happens, do these 4 things. And there are so many combinations of those 4 things that you cannot ever have a predetermined playbook to figure out those multiple signatures, and therefore having AI figure out dynamically what those playbooks are and making those API calls become more important. I'll stop there at the interest of time and give it back to the team to ask for more questions, etc. we conclude, Amit?
Yeah. We have some questions, Venkat. Let me. Uh, there's some things that I've received separately. Uh,
So there is one question from Amrita here I can tackle, which is which types of alerts benefit from AI-assisted triage, identity changes, network anomalies, API behavior. Instead of saying which type of alerts, I would put it in a different way. AI models are trained on activity that the internet has seen before. So if there are activities that are well known, then AI can recognize pretty effectively than a human. For example, EDR alert that a privilege escalation has happened from MF dash update, not even update, MF dash SVC's executable. Now, I don't know what MF dash whatever executable is. It could be malicious, it could be something that got dropped in, or it could be an update. If we put that into AI would be able to say, oh, that's from MF is McAfee, and therefore it's a virus update that's happening, and that privilege escalation is okay. And the reason why you is able to do that is because it has seen a lot of those alerts, a lot of those names, people talking on Reddit, people are talking on various forums, talking about that particular entity. So anything that that you regularly see people complaining about, people talking about, or vendors putting documentation on, that AI can assist very well. If this is a one-time thing that only your company has seen and nowhere else it has happened, then AI would not be able to, a regular model will not be able to help you. You need to have your own custom model. Good. Amit, you can take other questions.
but Venkat, just to keep it a little more engaging, the unsupervised kind of structure in AI, won't that be able to identify something new that comes up like this? Because uh, something that we have already seen will definitely come up, but going by the way the alerts are coming in, can't we train it in an unsupervised learning kind of structure in AI and see how it comes out?
Absolutely, you can. So I'm answering the question more from a LLM perspective, just plain models, plain LLM perspective. But definitely, you can use unsupervised learning and anomaly detection and so forth to be able to train it in such a way that it can detect things that it hasn't seen before as well.
Right. Some more interesting questions. Do you recommend separate pipelines for dev test alerting versus production to reduce unnecessary noise? So this is about two environments. You've created one environment for dev, one for prod. You don't want the noise from the dev to come and trouble, the SOC. So Kumkum, again, it depends on. I think Venkat, I can take this. So Kumkum, again, it depends on how you structure your solution and what kind of alerts you're looking at. So if you're looking at the technology and the security alerts from the infrastructure, then yes, they have to come to the SOC. But if you're looking at alerts from the code per se, then you can define your solution that the code alerts don't come in. The code alert should go into your software testing part of it, the SAST and the DAST part of it should not be coming to the SIM. Venkat, anything you want to add on this, or this is?
Sorry, yeah. Whether or not you need a dev and a prod environment, by not just for security, even for compliance, there are a lot of standards that dictate that your dev has to be different from prod. From an environment perspective, from a pipeline perspective, it is even more clear, as in there is dev environment and you have your pipeline. You merge to main, and then it deploys to dev, and it deploys to, if everything is good, QA and everything, you promote to prod, you promote staging, and you promote to prod. It's the same pipeline, but you change the tags. And when you change the tags of promote to stage, promote to prod, you would run different types of tests. to see what is appropriate for prod versus stage versus so irrespective of the pipeline, the tests that you need to run and the environment are different.
One more question that has come up is, how can SOCs balance AI automation with human analyst intuition? The human in the loop.
Yeah, right. In my opinion, there is a short term, there's a medium term and a long term. As in the triaging, the looking at the initial alerts, determining what additional investigative tasks that need to be done, running all the run books, all that, and looking at what needs to be done or what could have happened. All that packaging should be done by AI, and at the end recommendation of what to do should be made by a human. And that is where the security knowledge, the context, the experience, the company factors, that is where the human touch is needed. And that is where much of the security knowledge is needed, as opposed to just looking at statistical event type data or anomalies or making other calls to other systems. That is all should be done by AI.
Something that you can take beyond the human intervention or a human analyst intuition, you can take it to the context of critical systems where the principles of responsible AI come in. So not so much related to the SOC, but human intuition or human in the middle plays a very important role. So yes, analysis is fine, but if you want to take those changes and implement in some other place, you have to segregate between the systems which might require human intervention, which need not require. So again, it goes back into the design as to how you want to structure your process and your workflow. And if it requires, you put a human. If not, you leave it. But I think the question was very simple. I'm making it complex. As Venkat said, at some places you would need, some places you won't. Last question, Venkat, is what are the common mistakes when setting up cloud alert rules that AI tools can help mitigate?
I think the common mistake is trying to transfer the existing non-cloud on-prem rules into cloud. So if you not knowing how cloud works, the simple heuristic rules that I was saying, which is, hey, this is a service role versus a user account, or this is a AWS IP or AWS service IP versus an external IP. Things like that are very important. When I think about cloud, I don't see cloud as just AWS, Azure, etc., but I see cloud as the way that you operate things. CI/CD pipelines, having service accounts, no SSH access into your cloud environment, no instances, things like that is also part of cloud. And nailing that down would also make your life easy.
Right. I think we come to the end of the session. Thank you, all our listeners and all our viewers. It was a pleasure having you guys here. We will continue with this session. We will continue with the part 2 and the part 3 and the part 4, because decoding cloud alerts does not end this simply and with one session. There are tons of complexities. There are tons of opportunities, and there are tons of ways in which things are working. So, stay tuned. We will reach out to you and let you know about the next opportunity that we have when we share our views, when we tell you what we are doing, and we look forward to more sessions. Throw us your feedback. Let us know if you want us to include some specific things. If you want us to talk about something special, we will be listening. We will hear you, and we will include those things in the next chats when we have with you. So have a nice day, and have a great weekend. Thank you so much for tuning in. Bye.